The National Electrical Code, or NEC, addresses the installation of electrical receptacles, and understanding the requirements is crucial for safe and compliant installations. While the NEC doesn't explicitly prohibit all receptacles above ceilings, the acceptability depends on the specific application and the type of space above the ceiling. Generally, the space above a suspended ceiling is considered an accessible area. Article 100 of the NEC defines accessible as capable of being reached for inspection, maintenance, or removal without disturbing the building structure or finish. Receptacles can be installed above ceilings if they are readily accessible, meaning they can be reached without the need for tools or equipment to remove panels or other obstructions. However, this accessibility requirement often makes such installations impractical. One common application where receptacles are permitted above ceilings is for specific equipment, such as fire alarm systems, security systems, or other low-voltage systems. These systems often require dedicated power sources, and locating the receptacle above the ceiling can provide a clean and concealed installation. However, even in these cases, the receptacle must be accessible for maintenance and testing. Another consideration is the type of wiring method used to supply the receptacle. Flexible cords are generally prohibited as a substitute for the fixed wiring of a building, according to Section 400.8 of the NEC. This means that you cannot simply run a flexible cord from a junction box to a receptacle located above the ceiling. Instead, you must use an approved wiring method such as Type NM cable, Type AC cable, or conduit. Furthermore, any boxes and fittings used in the installation must be listed and approved for the intended use. Section 314 of the NEC provides detailed requirements for outlet, device, pole, and junction boxes, conduit bodies, fittings, and handle enclosures. It is essential to comply with these requirements to ensure a safe and reliable installation. There may be specific local codes or regulations that further restrict or prohibit the installation of receptacles above ceilings. It's always a good practice to check with a local electrical inspector or building department to determine the specific requirements in your area. Moving on to the topic of electrical safety and Hipot testing, both AC and DC Hipot tests are used to evaluate the insulation integrity of electrical equipment. However, they have different characteristics and applications. A Hipot test, short for high potential test, is a non-destructive test that applies a high voltage signal to the equipment under test to verify that the insulation can withstand the expected voltage stresses. The purpose of a Hipot test is to detect weaknesses in the insulation, such as cracks, pinholes, or contamination that could lead to insulation failure and electrical shock hazards. A DC Hipot test applies a direct current voltage to the equipment under test and measures the leakage current. The leakage current is the current that flows through the insulation due to the applied voltage. A high leakage current indicates a weakness in the insulation. One advantage of a DC Hipot test is that it can detect both resistive and capacitive leakage currents. Resistive leakage current is caused by conductive paths through the insulation, while capacitive leakage current is caused by the charging and discharging of the insulation capacitance. However, a DC Hipot test can also have some disadvantages. One disadvantage is that it can stress the insulation differently than an AC voltage. DC voltage can cause polarization of the insulation, which can lead to inaccurate test results. Additionally, DC Hipot tests can be more prone to causing insulation damage than AC Hipot tests. This is because the DC voltage can cause electrochemical reactions in the insulation, which can lead to degradation and failure. An AC Hipot test applies an alternating current voltage to the equipment under test and measures the leakage current. The leakage current is the current that flows through the insulation due to the applied voltage. A high leakage current indicates a weakness in the insulation. One advantage of an AC Hipot test is that it simulates the voltage stresses that the equipment will experience in normal operation. AC voltage causes both resistive and capacitive currents to flow through the insulation, which can reveal weaknesses that would not be detected by a DC Hipot test. Additionally, AC Hipot tests are generally less prone to causing insulation damage than DC Hipot tests. This is because the alternating voltage does not cause the same electrochemical reactions in the insulation as DC voltage. A tan delta test, also known as a dissipation factor test, is a type of AC Hipot test that measures the phase angle between the applied voltage and the resulting current. The tangent of this angle, known as the tan delta, is a measure of the insulation's dielectric losses. High tan delta values indicate increased dielectric losses, which can be caused by insulation degradation, contamination, or moisture. Tan delta testing can provide valuable information about the condition of the insulation, allowing for early detection of potential problems. One advantage of tan delta testing is that it can differentiate between different types of insulation problems. For example, high tan delta values at low frequencies can indicate moisture contamination, while high tan delta values at high frequencies can indicate insulation degradation. However, tan delta testing also has some limitations. One limitation is that it can be affected by temperature and humidity. It is essential to control these factors during the test to obtain accurate results. Another limitation is that it can be more complex and time-consuming than other types of Hipot tests. In summary, both AC and DC Hipot tests are valuable tools for evaluating the insulation integrity of electrical equipment. AC Hipot tests are generally preferred for simulating operating conditions and minimizing insulation damage, while DC Hipot tests can be useful for detecting specific types of insulation problems. Tan delta testing provides additional information about the condition of the insulation, allowing for early detection of potential problems. When performing Hipot testing, it is essential to follow the manufacturer's instructions and all applicable safety precautions. High voltage can be dangerous, and it is essential to take steps to protect yourself from electrical shock. One important safety precaution is to ensure that the equipment under test is properly grounded. This will help to prevent electrical shock in the event of an insulation failure. Another important safety precaution is to use insulated tools and equipment. This will help to protect you from contact with high voltage. Finally, it is essential to be aware of the potential hazards of Hipot testing and to take steps to minimize those hazards. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and working in a well-ventilated area. As for determining which edition of the National Electrical Code a specific state has adopted, there are several resources available. One option is to check the website of the state's Electrical Licensing Board or Building Code Agency. These agencies often publish information about the adopted codes and any amendments or supplements. Another option is to consult with a local electrical inspector or building official. They can provide information about the specific codes enforced in their jurisdiction. Additionally, several websites and publications track code adoptions across different states. These resources can be helpful for getting a general overview of code adoption trends, but it is always essential to verify the information with the official sources for the specific state or locality. In summary, regarding receptacles above ceilings, refer to the NEC, specifically Article 100 and Section 400.8, and always consult local codes. For Hipot testing, understand the differences between AC and DC methods, including the use of tan delta measurements for AC testing. To determine which edition of the National Electrical Code a state has adopted, refer to the state's Electrical Licensing Board or Building Code Agency, local electrical inspectors, or online code tracking resources.